curvilinear motion. I think you're familiar with this. Wait lang. Nagmo-move ba yung slide ko dyan sa inyo?
Yes po.
Nagmo-move. Thank you. We'll start now. So, curvilinear motion, I think na-introduce ko na sa inyo pag sinabing curvilinear motion. No? So, in dynamics, we have two kinds of motion, rectilinear and curvilinear. So, this is a quick differentiation lang. The body the motion of the body is passing through a straight line and passing through any 2 points of the body which remains parallel to its position, to its initial position. So, pag rectilinear, straight line lang. And we choose the origin of the motion on the path so that the magnitude and displacement vector could change. So, in rectilinear motion, we are free to choose kung ano yung origin ng motion na pag-i-analyze natin. For example, we say na yung motion will be starting from sa rectilinear motion. While in curvilinear motion, the body is moving along a curved path, no? Curved path or sometimes circular path, yung movement or yung ginagalawan ng ating body. Concentrated at its center of gravity and treated as particle in case of rectilinear motion. And the displacement vector will change both in magnitude and inclination. Although the velocity is always directed tangent to the curved path of motion, the acceleration is not tangent to the path. Okay, so we'll discuss it one by one. And basically, ang curvilinear motion, one of the example or topics under curvilinear motion is yung projectile motion na naituro na natin or na-discuss na natin nung ating prelim. Projectile motion. So in curvilinear motion, it occurs when a particle moves along a curved path. Since this path is often described in 3-dimension, vector analysis will be used to formulate the particle's position, velocity, and acceleration. Number 1, position. So in the figure dyan sa A, figure A na nandiyan sa inyong screen, consider a particle located at a point on a space, curve defined by a path function S. So the position of the particle is measured from a fixed point O, will be designated by the position vector R or yung radius na tinatawag. Since in every curve or a circle, di ba, meron tayong radius. Yun yung kanyang distance from the center of the circle. So that is the position in terms of radius. And yung S naman is just simply the arc or the curve length na tinatawag. Displacement. Suppose that during a time interval t, the particle moves along delta S or change in position defined by R prime or final R prime is equals to R plus delta R in figure. Dyan sa inyong figure. Mabilis lang to class ha, so mas maintindihan nyo kasi to with examples. And for velocity, average velocity is delta R over d, delta t. So basically class, kung mapapansin nyo, yung kanyang mga formula is just the same with rectilinear motion. Ang pinagkaiba lang dito, we're not studying only straight, no? So meron 2 dimensions siya. Meron siyang x and y component na tinatawag. Like dun sa ating projectile motion, may x and y component. Okay. So in curvilinear motion, ang ating acceleration is not only acting on the x-axis but also in the y-axis. Kaya meron tayong tinatawag na acceleration or tangent acceleration and normal acceleration. Okay, in summary, V is always tangent to the path and A is always tangent to the hodograph. Pag sinabing hodograph, yan yung kulay red line dyan sa inyong figure or yan yung path na tinatahak ng ating object. So, yung tangent or yung velocity daw is always tangent to that. Pero yung acceleration, because of the weight or the center of gravity, ang kanyang movement is always towards to the inside nung ating curve path or nung ating hodograph. Kaya dyan sa figure G, kung makikita nyo, yung acceleration natin is pointing papaloob or papunta dun towards dun sa gitna ng ating motion. So, sa loob ng ating motion. So, the most useful components of acceleration are those which are tangent and normal to the path. And these components denotes respectively the rate of change of magnitude and direction of velocities. So medyo mabilisan lang yan class ha. Wait lang. Yan. And this normal differ by the angle of delta, theta radians, and intersect at the center of the curvature for the segment. So, okay, wait lang. So, for example, we have a path or yung motion ng ating object is pag So, if yung motion ng ating object is pa ganyan, so we have y and x axis or x and y component niya. So, this is x sa horizontal and y for the vertical. And syempre, yung origin niya is yung center ng circle natin. Okay, our body is traveling from point A papunta sa point B. So, yung kanyang point, sa point A, meron siyang velocity, VA. And yung velocity, may point B, kapag nasa point B na siya, meron siyang velocity at B. So, the velocity is always tangent to the path. And since naka-curve yung ating hodogram or yung path na tinatravel ng ating object, yung kanyang distance or displacement will be r or yung radius. And yung kanilang difference or where it intersects na tinatawag. So, kunwari, ang kanyang initial is yung point A papunta sa point B. So, sa point B, this is r prime na, no? And yung kanilang difference or yung kanilang intersect will be theta or delta theta or radian. And for our acceleration, yung ating acceleration will always be having normal and tangent acceleration. So, if we have an acceleration here, no? So, meron siyang tangent. So, meron siyang tangent. So, meron siyang tangent to the path, acceleration t, and meron din siyang normal acceleration. And meron siyang tinatawag na resultant acceleration. Okay. So, yung kanyang resultant acceleration will be acceleration tangent squared plus acceleration normal squared and then square root. So, yan yung mga for our acceleration. And since and yung also yung velocity natin, aside from always being tangent to the path, meron din siyang x and y component. So if example, velocity at a, pwede siyang makuha as velocity a y squared. So ganyan yung kanilang formula. And again, for curvilinear motion, yung mga formula natin na ginamit sa rectilinear, yun pa rin ang ginagamit natin na formulas. Okay. So, para mas maintindihan dito sa ating first example, ano ba yung example niya? So, point A on the figure, hindi naman pala kompleto. So, this is point A, Y, and X. Drawing ko lang ah. If this is point B, so meron siyang acceleration tangent, and meron siyang acceleration normal. Drawing, sorry. And this is O yung center ng circle natin. And yung kanyang radius will be 20 feet. Dyan sa siya. And okay. So from point A in the figure, moves a circular path 20 feet radius. So its arc distance from initial velocity or initial position is B. So ang kanyang initial position is B is given by the relation S is equals to 6 t cubed minus 4t, where S is in feet and it is t is in seconds. So determine that tangential and normal components of the acceleration of the point for the instant when t is equals to 2 seconds. And find the resultant acceleration and magnitude in magnitude and inclination. So for our solution dito class, minus 40. And yung ating radius is 20 feet. Ang hinahanap sa atin for our A is yung kanyang tangential and normal acceleration or AT and A normal when t is equals to 2 seconds. Okay. So just like sa ating rectilinear motion, no, our velocity is ds dt, kung matatandaan nyo. So if s, to get the velocity, we must differentiate yung ating s. So ds with respect to dt is 6 multiplied by 3t and squared minus 4. So this will be 18t squared minus equals to ds over dt. So from there, makakuha natin si ating velocity, which is equals to 18. If the time t is 2 seconds, squared minus 4, our velocity will be Ano si velocity sa inyo? Velocity, 68 foot per second. So, if our velocity is 68 feet per second sa ating at time 2 seconds, what is AT and BT? So, for our AT, ang formula will be dv or the first derivative of our velocity with respect to time. So, if our v is equals to 18t squared minus 4, kapag kinuha natin yung kanyang first derivative, this will be 36t. Diba? Kaya yung ating acceleration tangent will be 36 multiplied by 2, which is 72 feet per second square. So, yan si AT squared. Si acceleration tangent. And then next, for normal acceleration naman, yung normal acceleration is towards or pointing dun sa ating center. Ano daw yung kanyang normal acceleration? So, ang formula dito is v squared over r or kanyang radius. If our velocity is 68 feet per second, so 68 squared, and the radius is 20 feet, our acceleration normal is kaya sumabay sa compute. 231.2 feet per second square. So, ayan yung ating sagot for the tangential and normal components of acceleration of the point from the instant when time or t is equals to 2 seconds. Nakuha ba? Nakuha? So, one question is find the resultant acceleration. Class, move na ako sa kabilang slide, ah. Okay. So, letter B is resultant acceleration. And inclination. Our resultant acceleration, this is square root of acceleration tangent or tangential acceleration squared plus normal acceleration squared. So, if our AT is 72 squared and yung normal acceleration natin is 231.2 squared and then square root silang lahat, no? So, our resultant acceleration is ano ang resultant acceleration? Two four 242.50 foot per feet per second square. So, ito si ating resultant. So, one last thing, ang hinahanap niya is yung ating inclination. So, sa figure natin, yung ating tangential acceleration at point A, no? Yung 80 daw natin is ganyan. Ito yung curve. Wait lang. It is normal. A normal. So, if this is our path, so therefore, yung kanyang acceleration, meron niyang resultant kasi meron siyang tangential and meron siyang normal. Yung resultant niya will be like this. Or ito yung ating. acceleration resultant. Okay. And ang hinahanap niya is kung ano yung kanyang bearing or yung kanyang inclination. So we say this is alpha. Oops. So S is equals to 63 minus 40. Therefore, S, or yung length ng curve natin, kung matatandaan nyo kanina ito, itong S natin, is 63 minus 40. If time is 2, S will be 40 feet. Diba? So 40 feet C. Okay, nakikita na yung figure, ano ko, yung presentation ko. Okay, so next. So, ang hinahanap is yung kanyang inclination dun sa ating circle. Okay, ito na lang yun. Sige. So, yung kanyang inclination or yung kanyang theta. So, again, ito yung ating resultant acceleration or AR. So, so ang hinahanap natin is yung kanyang theta. So, to get yung theta or yung kanyang inclination from point B papunta sa A, theta is equal to S over R. So, 40. If our S is 40 and our radius is 20, theta will be 2 rad of 1145.59 degrees. So, alam ba kung paano nakuha to? Yung 2 rad. So, 2 rad, 40 divided by 20 is 2. So, yung itong theta kasi natin is in terms of radian yan. So, therefore, we have to convert this into degree, no? Degree para makuha yung kanyang inclination. So, S over R, yung ating R or theta will be 2 rad or 2 radian and multiplied by 180 degree over pi para makuha yung kanyang degree or ma-convert sa degree 1145.59 or 0.6 degree. Okay. So, yung ating IP and AN, meron siyang so alpha. So, alpha. Hanapin natin kasi yung kanyang radian, yung kanyang inclination. So, ito yung kanyang magiging inclination. Ito na pala yun. Gawin natin um, pi. Pi yung kanyang inclination. Okay. So, ganito yung ating right triangle. Ito yung ating AN or normal acceleration. Meron tayong alpha. And meron tayong AT, itong AT, and merong AN. AT is 72 and 231.2 naman yung ating AN, feet per second square. So, para makuha si alpha, so this will be opposite over adjacent or tangent alpha is 72 over 231.2. Alpha will be 17.3 degrees. And to get yung ating inclination, this is simply pi. Mabaynos lang natin sila. So, yung value. 1145, 114.56 degrees minus 17.3 and this is 97.3 degrees. Yung kanyang inclination. Ito yun. Yung inclination ng ating normal. With respect to our x. To x. Okay? So the resultant acceleration is equals to at squared plus an squared and square root natin siya. So this is 242.15 feet per second square. Ang kanyang inclination with respect to x-axis is 97.3 degrees with respect to x. So again, in curvilinear motion, yung ating acceleration, meron siyang normal and tangential. And yung velocity, meron din siyang x and y component na mamaya sa ibang example makikita nyo kung paano sila kinukuha isa-isa. Okay. So nakasunod dyan sa ating unang problem. Okay na tayo sa unang problem. I-remind ko ulit kayo yung ating curvilinear motion, para lang din tong rectilinear motion. Ang pinakaiba lang, nasa curve path siya, therefore, meron siyang x and y component, katulad ng projectile motion natin. So, yung kanyang acceleration, may normal and may tangential. Okay, moving on na tayo. So, the procedure of analysis is using coordinate system. Yun nga, yung ds over dt And AT is dB over dt, or the first derivative of velocity with respect to time, or AdS is equals to VdS. Kung mapapansin nyo talaga, yung mga formula niya, also pareha sa rectilinear motion yan na na-discuss natin last time. And for constant acceleration or constant tangent acceleration, AT is constant if no, yung kanyang formula, initial or S is equals to initial velocity time plus 1 half AT squared, and velocity initial or final is equals to initial velocity plus AT, and final velocity squared is initial velocity squared plus 2AS, which is ginagamit natin talaga for uniform motion, uniform acceleration or constant acceleration. And for normal acceleration naman, the kanyang formula is AN is equals to P squared over P. Yung P is yung kanyang path, curve path. Ito yung formula. Okay? So, minsan, for normal acceleration, ginagamit natin, kung given si radius, normal is B given si radius. So, yan yung way to analyze yung problem regarding for curvilinear motion using coordinate system or x and y coordinate. Okay. So, example number two, class, determine the acceleration at the instant shown. So, meron daw tayong object moving on a circle or circular path. The radius is 1 meter. Yung kanyang velocity is 2 meter per second. And itong first derivative niya, or dv over dt, which is equals to the acceleration, 3 meter per second square. Pag nakakita kayo ng ganyan, no, yung v na may dot, first derivative with respect to time, or the acceleration t. Acceleration t, or tangential acceleration. Tangential acceleration. Okay. So, our AT, ang hinahanap is acceleration at instant. So, sabi niya, acceleration at the instant. Since curvilinear yung motion natin, ang hinahanap niya is yung ating resultant acceleration. Okay? So, for this figure, yung kanyang acceleration tangential, pointing, di ba, pa ganyan? So, that is our AT. So, meron pa rin tayong A normal, and yung ating acceleration resultant is ganito yung direction. No? AR. Ganyan yung kanyang direction. So, yung AR or the resultant acceleration yung hinahanap sa atin. Okay. So, yung ating given are velocity 2 meter per second and acceleration, tangential acceleration is 3 meter per second squared. So, the next is AN. AN is velocity squared over radius. If velocity is 2 meter per second, and then square, R is 1 meter. So, AN will be 4 meter per second square. For our resultant acceleration, square root of, so parang Pythagorean theorem lang, AT squared plus AN squared. So, 3 squared plus 4 squared, and then square root. A resultant is 5 meter per second square. So, yan yung ating sagot. Okay? Nakasunod pa dyan sa example number 2, letter A. Example number 2, letter A, okay na? Kung okay na, next tayo sa um, example number 2, letter B naman. Determine the increase of speed in the normal at the normal component of acceleration. Determine the increase in speed and the normal component of acceleration at s is equals to 2 meter. Okay. Ang given niya is, or yung kanyang condition is, kung S daw is 0, if the S daw is 0, hindi at, no, if S is equals to 0, velocity is 0, so ang hinahanap niya is the increase in speed. So pag sinabing increase in speed, velocity din naman yun, di ba? Speed and the normal acceleration. Okay. So for our solution, so first is our acceleration. So yung kanyang acceleration, ano pa yung given niya sa figure? So yung S niya is 2 meters and B are first derivative of B or 80 is equals to 4 meter per second squared. So ito yung kanyang A normal. So therefore yung kanyang acceleration resultant pa ganito. Pero ang hinahanap lang naman is yung ating A normal. A normal. Okay. So from our figure or our 80 is 4 meter per second squared. So for uniform motion or uniform acceleration, our final velocity is equals to initial velocity plus 2as, no, 2as. So ang hinahanap is increase of speed. So kapag daw yung ating s is 2 meters na, ano yung kanyang magiging final velocity? Final velocity if s is 2 meters. So this is squared. If s is, yung kanyang initial is 0, or initial or starting from s is 0, and velocity niya daw ay 0, kaya yung kanyang initial velocity is 0. Plus 2, acceleration is 4, or 80 natin, 4, and s is equals to 2 meters. So 2 times 4 times 2, and then square root is, velocity final is 4 meter per second. So yung kanyang increase in velocity after increase in speed or velocity at s is equals to 2 meters. Ano yon? Vladimir?
Okay na pala, ma'am. Okay na pala.
Ano pa mo? Okay. So increase in velocity is at s is 2 meters is 4 meter per second. Increase in velocity or yung final velocity niya, yung nang naging 2 meters yung kanyang s or yung kanyang displacement. And last is hinahanap is normal acceleration. So normal acceleration, again, this is p squared over r. So we will be using yung kanyang, since given yung radius natin na 2 meters, yung r yung gagamitin natin, and yung b final or yung b squared natin, yung velocity natin at 2 meters yung gagamitin natin for this b, no? So 4 squared over 2 is equals to 8 meter per second squared. So that is our normal acceleration for s is 2 meters. Sige, tingnan muna kung may tanong para makapag-move pa tayo ng iba pang problem. Actually, medyo mahaba itong curvilinear motion. Kulang. Kulang si 2 hours. Okay. So, move na tayo sa ating next problem. Okay, letter C. Determine the acceleration at the instant shown. The particle has a speed of 2 meter per second. Constant speed of 2 meter per second. Okay. Diyan sa figure natin, yung particle daw is moving, parang siguro nagbo-bounce siya, no? Nagbo-bounce-bounce. So, kanyang acceleration or yung kanyang tangential acceleration or yung kanya so the particle has a constant speed. So for this problem, sabi constant speed. So therefore, wala tayong um, acceleration tangential or wala tayong tangential acceleration. Kasi dito sa figure, ang given is 2 meter per second or yung kanyang velocity is 2 meter per second. So this is tangent or tangent to the path. So our AT is 0. Okay? Pero meron tayong normal acceleration which is pa ganito. So yung AT natin is 0. Kasi nga, constant yung kanyang motion or yung speed or uniform yung motion niya dun sa tangent natin. Okay? So, ang hinahanap is the acceleration at the instant shown. So, ang hinahanap dito is normal acceleration or the resultant acceleration. So, our AT is 0. So, ang kailangan na lang natin hanapin is yung kanyang normal acceleration. For our normal acceleration, this is velocity squared over P or R. So, wala tayong for today because yung ating curve is given as y is equals to 2x squared. 2x squared. Or yung nating masolve is yung ating P or yung path natin. Path. So, path is equals to 1 plus dy over dx squared and then 3 halves over second derivative of y with respect to x. So, yan yung hinahanap natin. Yung t. Okay. If y is equals to 2x squared, our dy dx is 4x. Wait lang kasi. Okay, tuloy tayo. Oh, wait, purahin ko pala 'to. balik ako. Sorry. Share ko na sa screen ko ulit. Sayang oras. Okay. Nakikita sa screen na? Nakakita na sa screen? Okay. So, the first thing we need to find is yung ating P or yung length ng path natin or ng ating curve. Okay. So, P is equals to 1 plus dy dx squared and then 3 halves, raised to 3 halves, the second derivative of y with respect to x. Okay. For our dy dx, no, yung y daw natin is 2x squared. Yung dy dx natin will be 4x. And yung second derivative ni y with respect to x is 4. Tama ba? Okay. So, therefore, if dyan sa figure natin, class, nakikita nyo, yung location ng ating particle at that instant is along sa y natin and sa x. So, ibig sabihin, yung kanyang x is equals to 0. So, x is equals to 0. Okay? So, if our x is 0, therefore, yung ating dy over dx is our p. So, p is 1 plus dy dx squared, which is 0, so squared, and then raised to 3 halves. So, mangyayari dyan is 1 lang siya, no? And then, yung b or second derivative of y with respect to x is equals to 4. Therefore, our p is 1/4. Yung p natin is 1/4. So, for that, an, substitute na natin yung b. Our v is 2 squared over 1/4 or yung kanyang p. Uy, bakit? Dito ko na lang lalagay si an. 1/4. So, 4 over 1/4 is si an. An is 16. Diba? 16 meter or meter per second square. So, for our acceleration resultant, AR, square root of AT squared plus AN squared. So, 0 squared plus 16 squared, square root. AR is 16 meter per second squared. So, yan yung ating letter C. Letter C. Ano yung acceleration resultant niya? Okay? Next. So, letter D naman tayo, class. May tanong pa ba dyan sa C? Kung wala na, D naman. Okay. So, sa letter D naman, Determine the normal tangential components and acceleration of S at S is equals to 0 if velocity is 4s plus 1. 4s plus 1. So what is the AT? AT. So pag sabi dito, nung ang S daw is 0, yung velocity is 4s plus 1. 4s plus 1 meter per second. So our solution is acceleration tangential, so dv over dt. So this is 4. 4, tama ba? dv over dt is 4. So yung ating acceleration or AT is 4 meter per second square. So, normal acceleration naman, yung hahanapin natin. Acceleration normal is velocity squared over r. Since meron tayong r dyan na 2 meters. 2 meters. Okay. So, what is our velocity? The velocity natin is given as 4s plus 1. If s daw is 0 plus 1, kaya this is 1 meter per second. So our normal acceleration is 1 squared over 2 or normal acceleration is 0.5 meter per second square. So normal acceleration and tangential acceleration. Acceleration. Okay. Okay, may tanong pa dyan. Letter D, may tanong. C, meron pa. So, pinapractice lang natin yung pagkuha class ng normal and tangential acceleration and yung kanyang resultant. So, next. So, dito naman sa letter E, wait lang, bukod natin. Okay, letter E. Okay. Letter E. Determine the acceleration at S is equals to 2 meters. If dv dt is 2s meter per second square, where s is in meters, at s is equals to 0, v is 1 meter per second yung kanyang given. No, if dapat kasi ito. If s is equals to 0, our velocity is 1 meter per second. So, ang hinahanap is yung instant na yung particle is moving with distance s na 2 meters. Ang kanyang radius is 3 meters. So, ang hinahanap is the acceleration. So, for this letter E, we will using ASDS or yung ATDS na tinatawag. ADS is equals to velocity dv or VdV. Kasi acceleration yung hinahanap natin. Okay. So our acceleration is, solve muna natin si AT. So, acceleration. Resultant pa rin yung hinahanap natin dito. Therefore, hanapin natin si AT and si normal acceleration para makuha si resultant acceleration. So, if we compute for our AT, so AT can be basically V velocity or dV over dt, ba? dV over dt. But for this example, yung atin daw velocity or yung ating S is equals to 2 meters, ang ating acceleration or dV over dt is equals to 2s meter per second squared. So, wala tayong velocity. Ang meron lang tayo is yung kanyang acceleration at um, tangential acceleration at that point. No? So, at that instant. Yan yung ating AT, which is 2s meter per second square. 2s meter per second square. So, kailangan natin si normal acceleration. Normal acceleration. Okay. So, with the formula or yung relationship na ADS-VD, VDB, or acceleration tangential, so this is 2s, yung 80 natin, 80, or ito no, A tangential is 2s ds is equals to VdV. VdV. So, para ma-solve yan, we have to integrate both sides as, so sabi dito, S daw is 0. If S is 0, and yung V naman is 1. So, we'll integrate both sides of our equation. Okay, so therefore, labas natin si 2 para mas simple. S ds is equals to V1 VdV. Okay. Integrate both sides. So, pag integrate natin si S ds, this will be ano, S squared over 2. And syempre, yung 2 nandun pa rin. So, pwede na natin siyang i-cancel. Ang kanyang limit is S and 0. S is equals to 0. And sa kabila, ganun din. If we differentiate or integrate yung VdB or VdB, this is product rule. Therefore, V V is or B squared, sorry, VdB product rule. V squared over 2. So, ito is, yung kanyang limit is V and 1. So, sa integration class, diba, yung kanyang limit, susubtract natin. So, as S is raised to 2 minus 0 raised to 2 is equals to V raised to 2, labas natin si 1 half, minus 1 raised to 2. So, S squared is equal to 1 half V squared minus 1. Okay? So, simplifying further yung ating equation, this will be 2s squared is equals to b squared minus 1. Or simply, para makuha si velocity, this is 2s squared plus 1 square root. Diba? If our s daw, if s is equals to 2 meter, yung kaninang condition natin, our velocity will be square root of 2 multiplied by 2 squared plus 1. Or 2 squared times 2 plus 1 square root. So, 3 meter per second. So, yan yung velocity at 2 meter yung ating S. Okay. So, 80 is now, for 80, solve na natin si 80, 2s meter per second. So, 2, our s is 2, therefore our acceleration tangential is 4 meter per second square. And then, for normal naman, an is velocity squared over r. And our velocity here is 3 meter per second square. So, 3 squared over 3. Therefore, this is 3 meter per second square sa ating an. So, kaya ang ating acceleration is, resultant is 4 squared plus 3 squared, square root, or AR is 5 meter per second square. So, that's our E, or letter E problem. Resultant acceleration yung hinahanap. So, 5 meter per second square. So, again, meron tayo laging acceleration tangential and normal acceleration. So, dito sa figure, ang ating AN will be, or yung ating acceleration resultant, or resultant acceleration, ganyan yung kanya itsura. Yung kanyang direction. Okay? So, that's the acceleration after 2 or 2 meters S. Next. Okay na ba sa letter E? Next na tayo So for F naman, determine the acceleration when time is 1 second and V is dt squared plus 2 meter per second. Where T is in seconds. So meron siyang acceleration 80 and meron siyang normal acceleration. And ang hinahanap sa atin is our resultant acceleration. Yun yung hinahanap. So, our V is 4t squared plus 2. And our t is 1 second. And radius natin is 6 meters. So, for our AT, or tangential acceleration, this is dv over dt. So, dt, or multiplied by v, which is t, 4t squared plus 2. So, AT will be 8t. 8t. And if t is equals to 1 second, therefore our acceleration tangential is a 8 meter per second square. So that's our AT, or acceleration tangential, or tangential acceleration. Next is our normal acceleration. So v squared over r. So if our v, or v is equals to 4t squared plus 2. So v will be 4 multiplied by 1 as time is 1. And 2. So 6 meter per second. So 6 squared over 6 kasi yung kanyang radius is 6. Therefore, our AN is 6 meter per second squared. And for our acceleration resultant, AN squared plus 80 squared, 6 squared plus 8 squared, then square root, or 10 meter per second squared. Our resultant acceleration. Okay, so yan yung mga ways kung paano or para mas ma-practice ninyo si normal and um, tangential acceleration and also the resultant. May tanong ba dyan sa ating 6 na problems for acceleration, normal, and tangential acceleration? Problem. Okay. So, kung wala na tanong dyan sa problems na yan, we now move on to our next problem. Oh, okay. So, ito naman. For a short time, the path of the plane in the figure is described as y is equals to 0.001 x squared. So, yun yung path niya. X squared pala to. X squared meter. If the plane is racing with constant upward velocity of 10 meter per second, determine the magnitudes of the velocity and acceleration of the plane when it reaches an altitude of 100 meters. So, yung plane daw natin is moving vertically upward or upward. Yung kanyang velocity is 10 meter per second. Yung kanyang velocity upward. So, pag sinabing upward, therefore that is yung kanyang V, Y. Y. Okay. And ano daw yung kanyang acceleration and velocity kapag na-reach na yung kanyang 100 meter na height dyan sa figure natin. What is kanyang? Yes? Na nagtaas ba? Hindi nag-move? Yes, Charlotte. Yan. Kita na? Okay, again. So, ano yung kanyang acceleration and velocity kapag na-reach na yung 1 meter, 100 meter na altitude or y is equals to 100 meter altitude. Itong y is equals to 0.11 x squared. Ito yung kanyang path, no? Ito yung path niya. So, hindi yan yung y na height niya. Yan yung kanyang yung y niya or yung kanyang altitude is or yung altitude niya is 100 meters. Okay. So, compute na natin. Ang kanyang hinahanap is if 100 meters, if 100, y is 100 meters, as yung kanyang y or yung path niya is computed as 0.11 x squared. So, we can compute for x using y. So, 100 is equals to 0.11 x squared. So, x is 316.2 meters. So, ito yung ating solution. So, dyan sa figure natin, makikita na kung ang kanyang altitude daw is nasa 100 meters height na, yung kanyang x now will be 316.2 meter. So, yan yung kanyang x. Using this path or yung formula ng kanyang path, no? Nakuha natin yung kanyang x component or yung distance x niya. So, next, what is data natin ng konti. Kulang talaga yung 2 hours natin dito class ha. So, I think kailangan ko ulit manghihiram ng ibang oras. Okay lang naman ba sa inyo yun? Kasi kayo din yung mahihirapan. So, pwede namang bibilisan ng pagturo, kaya lang, or kontian yung mga examples, kaya lang, hindi talaga obra. No, parang kulang talaga yung magiging kulang yung makukuha nyo sa amin or sa akin. Kasi nga, kulang yung oras. Diba? Kasi kung konting example lang, sigurado mas hindi lalong maiintindihan. Okay. So, x squared pala ko. Okay. So, determine the magnitudes of velocity and acceleration. So, hanapin natin yung kanyang velocity kapag nasa 100 meter altitude and x or departure is 316.2 meters. So, sabi dito, constant upward velocity. So, yung kanya daw velocity y is constant. Therefore, this is a uniform motion. And that is given that our Vy our constant velocity upward is 10 meter per second. 10 meter per second. So for constant velocity or uniform motion, our S is equals to velocity multiplied by time. So therefore, yung Y natin will be velocity Y multiplied by the time. Okay? If Y is 100 meter or yung 100 meter altitude niya, so velocity is 10 meter per second, we can compute the value of our time. So, as y is equal to 100, 10t, time is 10 seconds. So, makakarating pala siya sa 100 meter altitude at 10 seconds. So, yan yung ating time. And, yung ating d is equals to dy over dt. Diba? Change in displacement y or d dt as y is equals to 0.001 x squared. So, velocity y is 10. And kapag differentiate natin yung 0.1, this will be 0.002 x as x dx with respect to time, diba? With respect to time. So, 10 is equals to 0.002 x dx over dt is velocity inawan ko dx dt, di ba? So, dx dt is velocity x or velocity x. Velocity x. So, paano natin makuha si velocity x? 10 divided by 0.002. And yung x natin is 3 meters per 300. Okay. And x is equals to 316.2 Vx. So Vx will be 15.813 meter per second. Meter per second. Therefore, yung ating velocity is yung resultant niya for for that for that instant is Vx squared plus Vy squared. Kaya this is Vx is 15.813 squared plus 10 squared square root. So velocity at that rate or is 18.7 meters. So yan yung velocity niya at that instant. And lastly, yung hinahanap is yung kanyang acceleration naman. Acceleration naman. Okay. So, nasundan yung pagkuha ng velocity. Nasundan yung pagkuha ng velocity. Para acceleration naman yung ine-next natin. Anong problem? Okay. Acceleration naman yung next na hahanapin natin. So, our acceleration is letter B, yung kanyang acceleration. So, pag sinabing acceleration, resultant, no? Resultant. Okay. So, our dy or dB. So, acceleration naman tayo. So, acceleration at y or yung ating acceleration normal, this is the derivative of our velocity y with respect to time. Or d dt with respect to 0.002 x dx. So, kung natandaan nyo kanina, yung ating dy is equals to 0.002 x dx. Okay. Okay. So, sabi kanina, ang motion daw ng ating plane is constant velocity moving upward. So, pag sinabing constant velocity, yung kanyang acceleration y is 0. Diba? Constant velocity kasi. Upward. Kaya, 0 yung kanyang acceleration. Upward or yung kanyang y. So, therefore, 0 is equals to kunin natin yung differentiate natin ito. So, this is 0.002 x X and Vx. So, ito yung derivative of product rule to, no? Product rule. Tandaan nyo pa ba to? Product rule. So, dalawang variable siya, X and Vx. So, si 0.002, isasama ko, ilalabas ko muna. So, X. So, we have to differentiate itong XVX. XVX. Itong Vx kasi is V or velocity of X to, di ba? So, product rule. X, the derivative of V sub X is D Vx and plus Vx multiplied by Vx dt. So, product rule. Differentiate. So, product rule. Okay, 0 is 0.002. So, x and yung dvx over dt is our acceleration at x. Plus vx multiplied by dx over dt. Dx over dt is velocity x din. Kaya vx multiplied by vx. Kaya yung ating equation or will be 0.2 x acceleration of at x plus vx squared. X. Okay. So, from here, makukuha natin si acceleration at x. 0. Kung lilipat natin yung 0.002 dito sa kabila, this will be 0. Kaya x, ax plus velocity x squared na lang. Okay, 0. X natin is 316.2. Acceleration at x plus velocity x. So, velocity x natin kanina is 15.81 meter per second square. Kaya from here, makuha na natin si ax. So, pakitry kong compute kung ang lalabas ay point or negative 0.791 meter per second square. So, our acceleration resultant will be square root of ax squared plus ay squared. So, ax is negative 0.791 squared plus 0 or 0.791 meter per second squared. Our acceleration resultant. So, yan yung acceleration ng ating jet plane or nung plane kapag nasa 100 meter altitude na siya, moving with a constant upward velocity of 10 meter per second. Yan yung kanyang acceleration resultant. Okay, okay. So, I think meron pang time, no, na konti. Tatapusin ko na lang yung isang problem. Ano ba? So, isang problem na lang. Hindi na pala yan. Hirap ba to? Okay. So, one more problem. Kaya naman pala. So, one more problem. A race car, C, at point C, travels around, race car yan, race car, travels around the horizontal circular track that has a radius of 300 feet. If the car increases its speed at a constant rate of 7 feet per second square, starting from rest, determine the time needed for it to reach an acceleration of, wala ba? Okay. Okay, okay. Sige, sige, class. Dito na lang. Ano oras na ba? Okay, sige. So, siguro class yun na lang muna ang ating problem for today. Hanggang dun muna ako sa problem number 3. So, I will try to add more problems sa